Welcome back to another video tutorial. This time we're going to be taking a look at motion in 2 dimensions. So for this first problem, we have a cannon firing a cannonball horizontally off a 200-meter cliff with a velocity of 100 meters per second. And as we know by now, pictures help a lot. So I'm going to draw a picture of my cannonball, or my cannon. There's my cannon. It's going to launch this ball, and it's going to come and hit the ground over here. And I know the velocity of the ball is 100 meters per second, so I'm going to write that. And the cliff is 20 meters high. But it's starting here, and I am drawing down, so I need to make sure I write that as -20. Okay, and what am I trying to find? I'm trying to find how long, so I'm trying to find my t, and I'm trying to find the horizontal displacement. So I'm trying to find this displacement. Okay, so we're going to break this problem up into 2 parts, the y part and the x part. So let's start with the y part. So the y part, we're going to measure, we're doing the y part for the time. So we're going to imagine the cannonball is dropping straight down. So we're going to kind of imagine it dropping straight down, and we can do this because we know the time it takes to hit the ground here will be the same as the time it takes to hit the ground here. We learned that in class. So I'm just going to look at the down part, straight down, vertically, in this direction. Let's label our picture a little bit better. This is an initial velocity, and it's an initial velocity in the x direction. So I'm going to put VIX. This is in the y direction, the height of the cliff, so I'm going to put a y there. And my delta x at the bottom, I'm going to put in the x direction. So I'm going to kind of write these as x's and y's. The time doesn't matter because the time is the same in the x and the y. Whatever time we get in the x direction is the same as the time in the y direction. They're going to hit the ground x and y at the same time, so the time doesn't matter. Okay, so thinking about the y direction, my velocity in the y direction is 0. But wait, why is it 0? Isn't it 100? Well, it's 100 in the x direction. But what is it in the y direction? How fast is this ball moving in the y direction to start with? 0. So I'm going to put 0. And I'm looking for the time. I know the displacement is -20, and I also know my gravity's in the y direction, so I know A. Okay, so given this information, I can use an equation. I'm going to use x equals VIT, delta x equals VIT plus 1/2 AT squared. So I get -20 equals 0t plus 1/2 -10t squared. 0 times t is going to cancel. So I get -20 equals half of -10 is -5. That's looking pretty slick. I can divide by -5. And I'll get 4 equals t squared. And then I take the square root, and I get t equals, not 4, t equals 2 seconds. Awesome. So I know the ball is going to take 2 seconds to hit the ground, and it's going to take 2 seconds to hit the ground here or here. It's the same because they're independent of one another. So 2 seconds. Awesome. Now I'm going to do the X direction. So I'm going to do the X direction, and I'm going to use this to find the horizontal displacement or distance. So what do I know? I know the velocity in the X direction. I found that, I was given that right here. 100 is going 100 in the X, 100 in the X direction. So I'm going to put 100 here. I'm trying to find the distance in the X direction. That's my question mark. That's this down here. Okay. And I know the time. How long is it in the air for? I just found that. That's 2 seconds. So that is right here, 2 seconds. So I'm going to use the equation v equals delta x over t. So I get 100 equals delta x over 2. And I am going to cross multiply, which would give me delta x equals 100 times 2, which is 200 meters. Snazzy. All right, let's look at one more problem. This problem, we're firing a cannonball again, this time at a 30-degree angle with a velocity of 80, and we want to know how long will it be in the air. So I'm going to draw a picture again. My velocity is 80, and I have a 30-degree angle, and I'm trying to find the horizontal distance. So I'm trying to find delta x. All right, so we have an equation to find that. It is v squared sine of 2 times the angle divided by the acceleration of gravity. So I can just plug my number straight into that. So I get a distance in the x direction of 80 squared times the sine of 2 times 30 all over a, which is 10. So I have my v is 80, so that's this number. And then I have 30 degrees, that is my angle, that is right there. And then we know that a is 10 for the denominator. Okay. So we get delta x equals 6,400, that's 80 squared, times the sine of 60 over 10. And we can just put this in our calculators. Make sure that your calculator is in degrees, because this is 30 degrees. So we need to make sure the calculator is in degrees and not radians. If you're using Desmos, make sure that you convert it, change it, because Desmos defaults to radians. So make sure you switch it over to degrees. But if we put this in the calculator, we get a distance of 554.26 meters. And that's it. And to put in the calculator, I would just put 6,400 times sine 60, close parentheses, divided by 10. Just put it all at once. All right, hopefully you got that. Good job, guys. Good luck on the test. If you have any questions, let me know, and I'll see you soon.